Okay, next we'll talk about multiplying matrices. The first bullet says matrices A and B can be multiplied if and only if the number of columns in A equals the number of rows in B. Second bullet, if matrix A has dimensions m times n, where m is a number, n is a number, and matrix B has dimensions n times p, where n is a number, p is a number, but this n and this n have to be the same number, then the resulting dimension of AB is m times p. So if matrix A is an m by n, B is an n by p, you notice these are the same. It's like they cancel, and you're left with a resulting matrix of m times p. Directions say, use the matrices to the left, determine if the product is defined. If yes, give the dimensions of the resulting product. All right, number one says A times D. Here's matrix A. Look at the size. There's 4 rows and 3 columns, so it's a 4 by 3. Find matrix D. There's 3 rows and 1 column, which is a 3 by 1. You notice these 3's are the same, so they will cancel. And you can multiply, and the resulting matrix is a 4 by 1. Number 2, A times C. A is a 4 by 3. Let's find matrix C. There's 2 rows, 4 columns. These numbers are not the same, therefore you cannot multiply. Number 3, B times E. B is 1 row, 5 columns. E is 5 columns, 2 rows, so that's a 5 by 2. These numbers are the same, so we can multiply, and the resulting matrix is a 1 by 2. Okay, I'll let you refer to that answer key for the rest. How do you multiply matrices? The element in the nth row of an nth column of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and column N of matrix B. Show this pattern below. Okay, what that means is if this A is a 2 by 2, this B is a 2 by 2, therefore I can multiply because these 2's are the same. So the resulting matrix is going to be a 2 by 2. This is the way you would do it. I'm going to take the first row in matrix A and multiply it times the first column in matrix B. I'm going to pair those numbers up. So that would be A times E plus B times G. Okay, I'm going to this top row, second column, that entry, top row, second column. So I'll do A times F. You notice I skipped a little bit of space. A times F plus B times H. All right, I'm going to the second row, first column. So I'll do C times E plus D times G. All right, then I'm going to, this is the second row, second column, second row, second column. So C times F plus D times H. All right. 9 says to find the product. You have to check first if it's possible. This is a 2 by 2. This is a 2 by 2. Since these are the same, it is going to be possible, and the resulting matrix is a 2 by 2. All right, so I kind of think about that. I think about I'm going to have 1 row, 2 columns. This is the first row, first column. So that means then I'm going to match up first row, first column. -4 times 6 plus -9 times -5. Okay. I'm going right here. So this is the top row, second column. So that's going to be -4 times -1 plus -9 times 4. I'm going down here. That's the second row, first column. So 3 times 6 plus -2 times -5. This is the second row, second column. So that's going to be 3 times 6, -2 times 4. You go through, you punch those in the calculator, do them in your head, whichever you prefer. Combine like terms. So the first entry is going to be 21, because that's -24 plus 45. Right here, that's going to be 4 plus -36, which is -32. That's going to be 18 plus 10, which is 28. And that's 18 plus -8, which is -10. Oops, I got a mistake. So let's tweak right here. I apologize. Easy fix though. All right, this entry right here is the second row, second column. So that's going to be 3 times -1 plus -2 times 4. So that's going to be -3 plus -8, which is -11. All right, number 10 is a 2 by 2, 2 by 2. We can multiply. The resulting answer is -16, 6, 40, -54. All right, let's go to 11. It's a little different, so I'll work that one out. This is a 2 by 3. This matrix is a 3 by 1. These cancel, so the resulting matrix should be a 2 by 1. All right, so that means I'm going to have 2 rows, 1 column. So that means I'm going to have an answer that looks like this. So I kind of visualize that before I start. So first row, first column. So I'm going to do -7 times -6 plus 2 times 4 plus -11 times -3. Okay, down here, that's the second row, first column, second row, first column. So 3 times -6 plus -5 times 4 plus -2 times -3. I simplify, I add all that stuff together. So the result is top row is 83, bottom row is -32. Number 12, if I look at that one, this is a 1 by 2. This matrix is a 2 by 4. So the resulting matrix should be a 1 by 4, which means I have 1 row and 4 columns. So I can multiply. Let's do it. So first row, first column. So that's going to be 2 times 3 plus -8 times -2. That's going to be 6 plus 16. So the first entry is 22. Okay, I'm going to tell you what the remainder of this answer is, but you follow the same process. The second entry is 76, so I would do 2 times 10, -8 times -7, that's 76. The third one, I would do 2 times -4 plus -8 times 5, that's -48. And the last result, I would do first row, last column, 2 times -3 is -6, -8 times -6 is 48, so that result is 42. Number 13, same kind of process. This is a 2 by 2. This is a 2 by 3, so I can multiply, and the resulting matrix would be a 2 by 3. So if I started this one out for you, I would do top row, first column. So I would do 9 times negative 3 plus negative 5 times negative 1. Then I would do first row, second column, I'd put it here. First row, third column, put it here. Second row, first column here. Second row, second column there. Second row, third column there. I'd add, simplify. The final answer would be negative 22, 152, negative 55, and the bottom row is 2, negative 54, and 18. Okay, let's jump down and do 16. 16, first of all, this is a 1 by 2. This is a 2 by 1. So the resulting matrix would be a 1 by 1 because these would cancel. To do that problem, all I would have to do is multiply negative 7 times 16 plus negative 5 times negative 1. And the resulting matrix is negative 107. Number 17 says, given matrix A and B to the left, find AB and BA. What can you conclude from your results? All right, if I multiply A times B, that means I'm going to multiply matrix A first. Times matrix B. Okay, I can multiply 2 by 2 by 2 by 2. That result is going to be negative 13, 24. And second row is 48, 88. All right, B times A means I would start with matrix B, which is negative 2, 10, 7, 6, and I would multiply it by matrix A. This result is not going to be the same as multiplying A times B. So this result is 34, 82, and the bottom row is 45, 41. So therefore, AB is not equal to B times A. And you've learned that that's called the commutative property. So the commutative property is not true with matrices. Okay, there's some properties of matrix multiplication. Associative means the grouping symbols have changed. So if I have AB grouped together times C, that should be the same as A multiplied by BC. You know, parentheses means to do that first. So like I'd multiply AB, get that answer, multiply by C. That should give me the same answer as multiplying BC first and then multiplying A by that. The associative property of scalar multiplication, remember a scalar is a number in front. So if K is some number, remember we distribute that, that's going to equal KA times B, which is matrix A times the scalar K times matrix B. The left distributive property says C times A plus B, CA plus CB, And the right distributive property just means a C would be at the end. And that would be AC plus BC. We have two application problems. Number 18 says the first table shows the number of reams of paper, packs of dry erase markers, and boxes of staples requested by 2 teachers. The cost per item is given in the second column. Use matrix multiplication to show the total cost of the supplies. So Mr. Smith has 6 reams of paper, 4 markers, 5 staples. This is their cost, okay? So the paper costs $15, the markers cost $4, the staplers cost $2.50. All right, so this matrix right here, I'm just going to take the numbers out. So I got 6, 4, 5. That represents Mr. Smith. Mrs. Willis is 8, 2, and 3. I'm going to multiply it times the cost, which is $15, $4, and $2.50. This matrix is a 2 by 3. This is a 3 by 1. I can multiply. So when I do that, to kind of get you started, this is going to be the first row multiplied by the first column. So I would do 6 times 15 plus 4 times 4 plus 5 times $2.50. And now you notice that's Mr. Smith's cost. He bought 6 reams of paper, that cost this much. Markers, he bought 4, that cost this much. Staples, he bought 5, which cost that much. Same thing for Miss Wheels. We could take, she bought 8, so second row, first column. 8 times 15 plus 2 times 4 plus 3 times $2.50. Okay, the final answer. We'll talk about Mr. Smith first. This is the total amount that he made. Punch this in, you'll get your result, which is $118.50. Miss Willis, or Wheels, whoever she is, we can take the second row, punch those in the calculator, add up, get the total that she would have spent, which is $135.50. So matrices can be used in real life. It says used for questions 19 through 22. The students at Oak Hill High School are selling bags of popcorn for $10 each, tubs of cookie dough for $12 each, and baskets of fruit for $16 each to raise money for the school. The number of each item sold per class is shown below. 19 says if they earn 15% on each item that they sell, use matrix multiplication to show the profit earned by each class. Give your answers as a matrix. All right, I'm going to take those values from the chart. So 60, 84, 45, 75, 58, 28, 40, 63, 18, and I got this bottom row. All right, then I got 91, 47, 32. All right, so I've made that into a matrix. I'm going to multiply by the cost of each. So that's $1.50, $1.80, and $2.40. Okay, I will use matrix multiplication to solve that. My final answer would be, now you remember, I'm going to multiply top row times the first column. So 60 times $1.50 plus 84 times $1.80 plus 45 times $2.40. So that's $349.20. $284.10, $216.60, and lastly is $297.90. Which class earned the most profit? That would be the freshman. Give the total profit for the school. That's going to be $1,147.80. And lastly, how much more profit did the seniors earn than the juniors? That should be $81.30. Okay, Ms. White. And I think this video is going to be